Hi everyone. This is going to be a discussion about digital certificates. Actually, it's going to be a discussion about certificate management. And I want to stress this because it's important to understand that CySA Plus doesn't expect you to know everything about the life cycle of a certificate, as in how it is generated, how it is maintained, how it is distributed, what kind of algorithms go inside that certificate, what kind of fields we expect to find in the digital certificate, stuff like that. That's not the focus of the CySA Plus. That is part of the Security Plus exam and learning materials. All right, so just focusing on CySA Plus, we're going to talk a bit about how to manage digital certificates. All right, now hopefully you already know that digital certificates are the #1 method for authenticating or for proving the origin or the identity of a person, of a piece of code, of an email, of a website, of a machine. But certificates can also be used to facilitate digital signatures, and we can also use them to help us with encryption of data. Right, so let's have a better look at this concept. All right, so we have digital certificates, and we can assign digital certificates to people, to servers, to signed codes or applications. But in order for anyone or any kind of entity to trust them and to consider those certificates as being valid and useful, well, you need to recognize them as valid, and they need to be digitally signed by another entity that everybody trusts. Just like a national ID card, if you think about it, a password, or even a parking permit, or your university or high school diploma. If you trust the entity that signed that document, then you're going to trust the document as well, and whatever the document says. So for digital certificates, we have CAs. Those are certification authorities. That are the entities that issue those digital certificates. Now, not all CAs are trusted. In fact, you can actually become a CA yourself, by yourself, in just a few seconds. It's no big deal. You can start publishing certificates, but nobody would trust you because nobody knows you. Well, you might be able to convince some friends, perhaps, but generally, if you go outside in the wild web and you start issuing certificates, nobody is going to recognize them because they're going to see that, okay, they're signed by Andrew. Who the heck is Andrew? If I don't trust the owner of that certificate, why would I trust some Andrew nobody on the web? So we need some method to fix this, right? We need some method to ensure that at some point we can start trusting some authorities, right, that sign certificates. So trust has to start somewhere. So one solution for this is the fact that client machines, like operating systems that we're running on our desktops or laptops, even our mobile phones, even our smartphones, come with pre-installed so-called root CA certificates, which are trusted by default. They use them to validate websites that use HTTPS. That's why when you visit Gmail or Microsoft or any website basically nowadays, you're going to see the log icon in your browser that says the connection is secure, the website is trusted, and everything is okay. You're safe to provide your credit card details over that encrypted connection. We also use them in our computers to validate email signatures. Now, not everybody signs their emails, I know, but that's the same process. Also, VPN connections. Sometimes when you connect to a VPN endpoint, you might receive a message that says the remote location is not trusted, or the certificate is invalid. And this very often happens, especially in smaller companies that use self-signed certificates. When people try to connect from the outside to that VPN endpoint, they're not going to trust that certificate, or the VPN client is not going to trust the certificate. Now, you might be able to override this and say, okay, I know what I'm doing, just go ahead and connect. But that's not the secure way of connecting over an unsecure network such as the internet. All right, so just to recap, we can use digital certificates to verify identities for people, like in email signatures, or for web servers, for example, when you're accessing them using a browser. We can use them for non-repudiation. Remember, non-repudiation is the inability of someone, of a person, of an entity, of denying having sent a message. If we trust that only that specific person has the valid key that can be used to sign an email message or to encrypt a specific file, then there's no way for that person to deny ever having done that action because nobody else could have done it in their place. So that's non-repudiation. This is also one of the things that we get, one of the benefits that we get by using digital certificates. Electronic signatures, just like we said before, we can sign our messages, we can sign our code as well whenever you're distributing binary code or applications to your customers, to your clients. That code, that signature attached to your code, that's a confirmation for the end user that the code actually came from you and not from a malicious third party. And finally, encryption. Now, there's an entire discussion here going from public-private key cryptography, so from asymmetric cryptography to symmetric cryptography, and what exactly happens whenever you establish a secure tunnel like an IPsec tunnel or a TLS tunnel. That's beyond the scope of the CySA Plus. Again, this is also covered in the Network and Security Plus courses from CompTIA. But suffice to say that digital certificates can help us with securing data sent over an encrypted connection, first by authenticating the endpoints so that we can be sure that Alice is communicating with Bob and there's nobody in between and nobody's impersonating anyone, and also gives us a secure environment where we can decide what kind of encryption method, what kind of encryption key are we going to use in order to send a big amount of data, a large amount of data. Some of the tools that you can use to view your own certificates start with the CertMGR utility in Windows. That's a certificate manager. So right here we can see on the left hand side that we have personal certificates, trusted root certificate authorities, and a bunch of other certificate categories. For example, on the personal section, if I collapse this one, I'm going to see my own certificates and a couple of company certificates that I've manually imported. The trusted root certificates, again, this is going to include all the trusted CAs that my computer knows about. So if right now I visit an HTTPS website, which is directly signed by CertSign, all right, or it is signed by a CA that is signed by CertSign, then I'm going to automatically trust that website. I'm going to trust that connection. Another way to view my current certificates, my personal certificates, is by using the SigCheck utility. This one is available within the sysinternal package, freely available from the Microsoft website. So sigcheck.exe-tv, right, is going to show me the trusted and valid certificates that I currently have installed on my computer. Now, apparently, I also have a certificate from Blizzard. Don't remember playing anything from Blizzard, but anyway, apparently this one is here as well. All right, and as I just mentioned, this is internal suite of utilities is freely available on the Microsoft website. I'm gonna leave the link in the video description. Go ahead and download that package because it has a bunch of very useful utilities for the Windows environment. One additional thing to note is that some applications will maintain a separate certificate store just for themselves, like for example VPN clients or even web browsers. So for example in Firefox, if I were to head to the settings section and search for certificates right here, right, I can click on view certificates and I'm being presented with a certificate manager which is completely separate from what we saw before. And this is the set of certificates that is built in every Firefox browser, so they're automatically trusted. One more interesting thing to remember is the fact that there is something called the Certificate Transparency Framework, which is nothing else than a grouping of major companies that agreed among themselves to publish their own CA logs. That is, anybody could see actually with what kind of domains, what kind of subdomains they've published certificates for. So from a reconnaissance point of view, as an attacker, or as a security analyst, there's a lot of useful information that can be discovered in these public logs of the CAs as well. So go ahead, start from this website right here, and then navigate to one of these major vendors at the bottom. Also remember that certificates might not identify a specific entity, just one specific server, for example, because we do have two additional types of special certificates. The first one is called a SAN, that is a subject alternative name. This is the kind of certificate that can be used with other domains closely related domains from the parent domain for which the certificate applies. We can also use it if our website is hosted on different IP addresses, or we want to also use it to validate or use it as a signature for email, or if you want to create some subdomains for email addresses. This is useful when you have a certificate for your business, but you don't want to purchase another certificate for each and every resource that you're hosting. So it's a way to use the same certificate for multiple resources. And another kind of certificate that kind of does pretty much the same thing is a wildcard certificate. This one is a bit more broad because it covers a larger spectrum of possible domain names. This one applies to all the subdomains. For example, multiple unrelated hosts that all belong to the same company. Doesn't matter which host it is. So this one will attempt to automatically validate or confirm the identity of any entity that is under your control inside of your company. Careful with this one, it might apply to multiple completely unrelated entities. It's gonna make forensics and logging extremely difficult because it makes it very hard to identify which entity you're actually talking to. But again, it's another solution if you don't want to purchase a specific certificate for each and every subdomain or each and every resource that you own. All right, so from an analyst perspective, from a security analyst perspective, the daily certificate management tasks are most likely going to include things along the lines of, well, the installation of certificates onto new network devices, web applications, internal servers, updating those certificates whenever they need to be replaced or renewed, validating the root certificates, because sometimes they get compromised, and a root key compromise means that all the certificates ever generated by that CA become compromised as well. Then, of course, we're going to be focusing on installing, updating, and revoking user and machine certificates. Be very careful here with code signing certificates, those that we use to sign application code, because they can be used to push malware using properly signed code. And just to give you an example for this, what can you do if you manage to get a hold of Apple's signing certificates for their own applications in the App Store? Well, you get the chance to put hacked applications, malware applications, onto iOS devices. Now that's like the holy grail of hackers, right? And it actually happened not so long ago. All right, other than that, be very careful with self-signed certificates. They are very convenient because anybody can generate them, but they rely on user awareness. They cannot be used to validate any kind of identity, because if you're stating your own identity and nobody can vouch for you, then that statement means nothing, okay? Also, careful with self-signed certificates because captive portals, especially those in public Wi-Fi's, you know, those wireless networks that redirect you to a sign-in portal the moment you connect to that public Wi-Fi. Captive portals usually have these self-signed certificates in order to inspect the traffic that you are sending. Yes, they are doing man in the middle, but they will be doing it only if you agree to accept and install their own certificate. So careful with accepting certificates on public wireless networks. Most likely it's going to lead to some man-in-the-middle traffic inspection. It might be just to secure the web access, but it most likely it's going to be malicious. Especially since most people, when they see a warning and it does have an accept button, they will press the accept button because they want to have internet access. They don't really care what it says. But anybody can create a captive portal, including a hacker trying to steal your credentials, right? You just clicked on accept and continue, and you've given all your traffic from now on to be captured by the attacker. Be sure to revoke untrusted certificates as soon as possible. We actually have two methods that allow you to check if a certificate has been revoked by its certification authority. And those methods are CRL, that is the certificate revocation list, which is, well, just like the name says, is the list published by the CA that can be downloaded and checked, which includes all the serial numbers of all the certificates that have been revoked by that CA. Now, of course, it's up to the client, the one that actually validates any kind of certificates it receives, to download this list periodically and, well, double check all those certificates if they're not found in that list before accepting them. Now, there are some problems with CRLs, of course. As you can see, downloading that list every single time you need to validate a certificate is not very efficient or convenient. It's a lot of overhead. And secondly, CRLs are most likely not published instantaneously. That is, it's going to be a delay which can range from a couple of minutes perhaps to a few days or weeks before the CRL is updated, and another piece of delay before the actual entities that need to validate certificates think about, downloading an updated version of that CRL. So it's not very efficient. Some certificates might get through even though they have been revoked. So we have a better method. This is called OCSP. This is the Online Certificate Status Protocol. And just like the name says, it's a way to online verify if the status of the certificate is okay or not, if the certificate is revoked or not. It's basically, instead of downloading the entire list of revoked certificates, you're running a query and reply conversation with the CA just by asking, dear CA, just please let me know if this serial number has been revoked or not, and the CA replies immediately. Now, the behavior is a bit high traffic, is a bit more interactive, so this might consume some resources on both sides. So we do have some methods of optimizing this by caching those responses on the web server itself, and that's called OCSP stapling. This, on the other hand, is a discussion for the Security Plus training, right? So we don't need to know this for the CySA Plus. For the CySA Plus exam, it's more than enough for you to know the differences between CRL and OCSP. And a couple of utilities you should know about for managing certificates on both Linux and Windows. We have OpenSSL on Linux and CertUtil on Windows. All right, short discussion here about SSL and TLS. As you hopefully already know, websites that use HTTPS as a communication protocol, which is a secure protocol, well, that protocol is secure because it uses TLS in the backend. So in order to be able to implement TLS, we need the server to have a valid certificate, because when you're trying to communicate with that server, your browser basically receives that certificate from the web server, checks the signature on that certificate, checks to see if the certificate has been signed by a valid, a trusted CA, and if it has been, then it's going to trust that certificate and it's going to trust the entire communication with that website from that moment on. Now, in the background, what really happens is after we're accepting that certificate, so we are validating the identity of that website, we are negotiating some encryption algorithm and some encryption keys that will be used to transfer all the data between my browser and the specific website. Now, it is also possible to have the client authenticate itself with a certificate as well. This is not often used, but it can be done so that the server trusts the client as well. Usually the client has other means of providing its identities, like usernames, passwords, one-time passwords, and so on, multi-factor authentication. But, well, one of those factors could actually be something that you have, that something being a certificate. Most likely this feature is used in VPN connections, not so much on the web, and in enterprise networks that require this kind of mutual authentication. Now, one thing to really understand here is the fact that SSL from version 3.0 on has become TLS version 1.0. Right now, SSL by itself is not considered secure anymore. Actually, not even TLS 1.0, but you should be seeing at least TLS 1.2 on every website that you're visiting, if not even TLS 1.3. So don't try, if you're managing a website, if you're managing anything that uses TLS encryption, try not to use anything lower, any previous version prior to 1.2. And God forbid that you use SSL. Also, keep in mind that most people still refer to TLS as SSL, even though the real protocol in there is actually TLS. But we've gotten so used to the SSL terminology that we still call an encrypted HTTPS connection HTTP over SSL. And that's just because people have gotten used to the SSL term. Now, of course, since we said that the protocol itself is used to negotiate a specific encryption algorithm and encryption key, well, the protocol itself first has to be supported, allowed on both the server and the client. Which means if you're using an older browser, an a browser that hasn't been updated in some time, well, the browser might not know anything above TLS 1.0, 1.1, in which case it depends on the website if they agree to downgrade their TLS version in order to talk using the same version as the one supported by the client. Most likely this kind of downgrade is not done for malicious purposes, but it is performed so that we can find the highest version number that we can both use. Unfortunately, it can also be abused. So an attacker can force a web server to downgrade its encryption algorithm down to the lowest possible version. Why? Well, because lower versions, older versions have vulnerabilities in there. They're much easier to attack. So careful with this. You might have a website that by default is going to present itself as TLS 1.2, but there might be some settings in there which you might have overlooked that allow that website to downgrade to very, very old cipher suits and very, very old SSL versions even. Now, since 2018, we have TLS 1.3, and it brought on some big improvements, especially regarding this downgrade attack. So it's basically now preventing TLS from ever downgrading to an unsecure version. And there are also changes in the handshake protocol that is performed between the client and the server in order to reduce the number of messages and speed up the connection. These types of vulnerabilities, given by the version of SSL or TLS, can be easily detected by any vulnerability scanner or web application scanner, as these are among the first things that a web server is going to report to a client whenever they try to initiate a connection. These are the supported algorithms and supported protocols that I can use. Pick one. And just to end with a couple of examples, we've got the certutil utility on Windows. You can ask for more information using the --. And you can see we have this utility here that we can use to generate certificates, enumerate them, back up from AD, restore them to the AD, import certificate from external files, and so on and so forth. So we really have a lot of functionality within this very small utility. And we can also use it to list our own certificates in our own certificate store on local machine using the -store parameter. Now, if you move over to a Linux prompt, here we have the OpenSSL utility. Can prefix this using the man command so we can access the man page. And if we scroll down here, we can see under the description that this is a utility that we can use to manage the creation of private keys, public key cryptographic operations, creation of standard certificates, CSRs and CRLs. So these are the certificate signing requests. When you apply for a certificate, you want to get a certificate. So you basically fill a form and you send it to the CA in order for them to generate the certificate for you. And CRLs, the ones that we've just talked about, certificate revocation lists. All right, so just remember these two utilities for the exam. And one more tool here that I want to show you. Of course, it's just one of the many tools out there that you can use to check the sanity and the validity of the certificates that you're using on your web applications or websites. Is this one right here from DigiCert. You can just click on this Check SSL TLS certificate button on the left. Now let's add something like, I don't know, YouTube. All right, click check here. And just a couple of seconds here is going to give us a lot of information about who generated the certificate for YouTube, what kind of validation we have, domain validation, what's the algorithm type that is being used, the key size, the serial number, a revocation check method here, by the way, OCSP, right? The one that we've just talked about. Let's see, what else do we have here? These are the SANs, subject alternative names. Remember these? Look how many of them are, right? They are all related, of course, to Google and YouTube in some way. And of course, at the very end of the page, you can see if the certificate is still valid. So use this one, especially if you own a website, if you own a company, just perform some sanity check on your certificates from time to time. Right, so by now you should have a pretty good understanding about what are the generic certificate management tasks that an admin is supposed to perform on a daily basis. And for the exam, make sure you remember those special certificate types like the SAN, subject alternative names, and the wildcard certificates. Also, make sure you understand the difference between OpenSSL and TLS, how are they implemented and why the version is relevant. Make sure you are able to at least recognize a couple of the command line utilities involved in certificate management. And last but not least, Thank you so much for watching, like and subscribe, and see you next time when we're going to be talking about mobile threats. See you.